Okay, well, let's keep going then. Okay, I'm hoping to get, I don't know if we'll get to it, but although it's a short worksheet, basically, well, I'm hoping to get to a very short worksheet. It's only like 2 questions on it, but we'll see. Okay, here's an example. I was going to have you guys try this, but I really want to try out that worksheet. So let's just do this one together. So here, this one's going to be a little bit different, okay? This one's going to be a little bit different in that here, I'm giving you the circumference of the circle. I'm giving you the circumference of the circle, right? Here, we had the radius and we got the circumference, right? Here, we're basically going the other way around. Namely, I'm telling you this is the circumference of the circle. Let's find the radius. Okay? So we have 2 problems where we're doing that. Namely, for 62.8 feet, okay? For this one, since this is the circumference and we want to get the radius, we know that the circumference is 2 times pi times r. So this has to equal to 2 times pi times r. Okay. Now, I just rewrote it as 2 pi r equals 62.8 feet. I mean, really what you want to solve for should always be put on the left side. I mean, if you have it on the right side in this class, I'm not going to take off points. But anyway, we have 2 pi r, right? That's what the circumference is in terms of r, has to equal to this. So now it's just solving for r, right? So what do? We divide by 2 pi. We divide both sides by 2 pi, like so, right? And when we do that, let me see if I can draw it in actually. When we do that, these are going to cancel. We get 62.8 feet divided by 2 pi. And what's left on the left is r. So we get r equals 62.8 feet over 2 pi, okay? And if you did that in the calculator, you will get something like this. Again, I'm using more than 2 decimal places because I'm telling it to round to 2 decimal places. So I'm using 4 here. I think before in the other problem I used 5, but as long as you're using more than 2, that's fine. But to round it to 2 decimal places, right? We go to the second decimal place. We look at the third. It's a 4, which is less than 5. So the 9 here doesn't change. So the radius is about 9.99 feet. So it's about 9.99 feet. Okay. And the same thing over here, right? Again, it's the same exact process. We have 12.6 feet. Again, this is circumference, so this equals 2 pi times r. So 2 pi r we have is 12.6 feet. And it's the same thing. We want to get r, right? So what do? We divide both sides by 2 pi. So these are going to cancel. We divide, these cancel. We get r is 12.6 feet over 2 pi. And again, you can just do that in the calculator here. And you end up getting this. Okay.
So
yeah.
When you plug it into the calculator, you put you have to do 2 times pi first.
Oh yeah, you know what? Let me show you guys how to. Let me show you how to do that actually. Yeah, let me get my calculator, okay?
Okay.
Okay. I'm glad actually someone asked that. So, because I was wondering, I wonder if they'll know how to do that in the calculator. So, whoa, wrong button. Sorry. Okay. So here's what I did. So what I do, I use the parentheses here. So I'm going to do 12.6, right? Then I'm going to divide and then use parentheses. 2 times pi, close parentheses, See? And then we press enter. And so we get this. Does that make sense what I did?
Yeah. So the first number that you got, the 6.283, that was 2 times pi.
Oh, I could do that also.
No.
60.
Oh.
Okay, 62, sorry, 0.8
Mm-hmm.
divided by parentheses 2 times pi, close parentheses, equals. Does that make sense?
Yes, it does. Thank you.
Okay, good. Okay. I think calculators have parentheses in them. So, I mean, if you didn't have parentheses, you could do 2 times pi first, but then use a lot more than 2 decimal places. I would use like 4 or more, and then divide that by, and then do 62.8 divided by that. I mean, if you ever need help using a calculator, don't be afraid to ask me, during class, office hours, or whatever. So, yeah. But if you don't ask me, then I'll just assume you know how to use it. So, all right. Okay. Any other questions? Okay. So let me see. I think here, let me share the slides again. If I remember, I think the next thing is the worksheet time. Yes, it is. Okay. So what I was going to do now is share a worksheet. We only have 5 minutes though. I'll let you try one of the questions. Let me do that. So if I remember correctly, I think I did email you guys the worksheet as well. So let me get the worksheet. It was a short one I just made. Here we go. Hope everyone can see it. See, can you see? Yeah, there we go. I think so with number 1, those are questions like we did before with Pythagorean's theorem. Can you have a right triangle with these 3 sides? And number 2 here, I don't know if you can see it, but number 2 down here, okay? Here, this is where you want to find the radius and diameter of each circle, but now we're given the area, okay? Here, we're actually given the area instead. So I think for time consideration, just thinking, see, we only have about 4 minutes. So I'm thinking it might be good if we just do these together. Yeah. I actually have the answers worked out already. So let me share that with you, okay? Can everyone see this? Here it comes. There it is. Good, good. Okay. This is actually the first one. If you can have a right triangle with these 3 side lanes. Again, someone I think asked this earlier also. You always take the longest side to be the hypotenuse. I mean, basically what you're going to do is you're going to assume that we have a right triangle with these 3 side lanes. And we have to check if Pythagorean's theorem holds. That's what we have to check. Okay, and the longest side would have to be the hypotenuse. I know with triangles, with triangles, the side opposite the biggest angle is always the longest side. So the other 2 sides would have to be just legs. Okay, so let's say we have a right triangle like this. So this side, the longest, would be the hypotenuse. This side, and so the other two numbers would be legs. And we check, does Pythagorean's theorem hold? And that's what I'm checking here. And you can work this out in your calculator. It's actually a little strange, this one, because as you can see, this equation is true. So in this case, we could have a right triangle. So in this case, the answer would be it is possible. We're not saying there necessarily is one, but it is possible though. So here, our answer is it is possible because Pythagorean's theorem does hold.
So
Yeah,
the biggest one is always the hypotenuse.
exactly. Always opposite the 90-degree angle.
The other two can be placed either in A and B. It doesn't matter.
Right, it doesn't matter, yeah.
Okay.
Awesome question. Any other questions?
Yeah, I just have one more question. Like on like a quiz or a test, like if we get like the right answer and then we say yes, it's possible, or no, it's not possible, do we have to say like yes, it is possible because Pythagorean's theorem says this or that, or can we just say yes, it's possible with our work shown and that's the answer?
If I tell you to explain, then you would have to say it is possible because Pythagorean's theorem does hold. Or, no, it's not possible because Pythagorean's theorem does not hold. If I tell you to explain the answer, then you would have to write something like that. But if I just say, if I just give you the question, then you could just do this.
Okay, cool. Thank you.
Awesome question. Okay, so yeah. Someone had another question?
Yeah, I have a quick question about the circumference that we just did. On a test, would you want us to keep our answer in pi form, or do you want the exact answer?
If I say exact form, then you can leave it in terms of pi. If I say round your answer, then you would have to round it to decimal places.
Okay, no problem.
Okay, awesome. We're actually out of time now, so let me stop here.